themselves, all lines of dielectric force terminate on conductors, but may form closed loops in electromagnetic radiation. These represent the basic laws of lines of force. It can be seen from these laws that any line of force cannot just end in space. We've pretty much seen this graphically already, so let's continue. Faraday felt strongly that action at a distance is not possible through empty space. Or in other words, matter cannot act where it is not. He considered space pervaded with these lines of force. Almost everyone is familiar with the patterns formed by iron filings around magnets. These filings act as numerous tiny compasses and orientate themselves along the lines of force existing around the poles of a magnet. We saw this in the picture further back. Experiment has indicated that a magnetic field does possess a fibrous construction. By passing a coil of wire through a strong magnetic field and listening to the coil output in a pair of headphones, the experimenter will notice the scraping noise, in other words, the sound of the lines of force breaking on the conductors. J.J. Thomson performed further experiments involving ionization of gases that indicate the field is not continuous, but it's a fibrous structure. He presents this in his book, Electricity and Matter, in 1906. This is where he developed the concept of the electron. Okay, we'll keep going. Consider the space between poles of a magnet or a capacitor as full lines of electric force. And we've already seen the pictures. These lines of force act as a quantity of stretched and mutually repellent springs. Anyone who has pushed together the like poles of two magnets has felt this springy mass. Okay, we've seen the figures. We've gone through all that. Consider the, okay, we're going, let's go back to the diagram. Let's go all the way back. Can we go back to the flux diagrams?
Sure.
Keep going.
This one.
Okay, this is what we're talking about here. This diagram of attraction, and the next diagram of repulsion. This is what we're, so I'll read the text, so you have to keep this in mind. It's hard to do stuff in a serial fashion, but so if we can move back to the okay, so now we're talking about, okay, in figure 1, the lines of force are more dense along AB between the poles, and that more lines on A are facing B that are projecting outwards to infinity. So in other words, the lines are in between the two objects. Considering the effects of the lines of force on A, these lines are in a state of tension and pull on A, because more are pulling on A towards B than those pulling on A away from B. We have what appears to be the phenomenon of physical attraction. Now we observe from figure 1, notice how that the poles are like rather than unlike. This is the second diagram. Where all lines pull A away from B, just as the phenomenon of physical repulsion. The lines of force can be more clearly understood by representation of it as a tube of force or a long, thin cylinder. Maxwell presented the idea that the tension of a tube of force is representative of electric force in volts per inch. And in addition to this tension, there is a medium through which these tubes pass. There exists a hydrostatic pressure against this media, what's called the ether. The value of this pressure is 1/2 the product of the dielectric and magnetic density, which these terms we've already encountered. Then there is a pressure at right angles to the electric tubes of force. If through the growth of a field the tubes of force spread sideways or in width, the broadside drag through the medium represents the magnetic reaction to the growth and intensity of an electric current. However, if a tube of force is caused to move endwise, it will glide through the medium with little or no drag as if little surface is offered. This is the opposite type of wave to the electromagnetic wave. The first one, sideways movement of the lines of force, is like moving a sail through the atmosphere. There must be a reaction. So if the dielectric lines of force represent the sail, if it's moving sideways through the space, then the air movement represents the magnetic reaction, and the energy of the entire system then can be called electromagnetic in analogy. But if the lines of force, if the sail is made to move sideways, there is no drag through the air, there is no velocity of light, there is no magnetic field, and now we have the world of Nikola Tesla. This is the type of transmission he was using.
Well, the reason I wanted to ask about the frame drag aspect of a rotating planet like Earth, because I would theorize, based on the model you're presenting, which I think is interesting, that the density patterns of the ether would be different at different parts of the Earth's surface. You would have a radically different ether pattern at the equator, than you would at the poles. I was kind of wondering if that in some way fits into the...
Well, see, unfortunately, these things have never really been worked out. That's why they gave up on the ether.
But nonetheless, I mean, if an experiment were to be designed with this idea in mind, would that be one of the things you would want to look at?
Well, obviously, the thing is to try to get a better understanding of how this all relates to, is the ether more dense in one part of the solar system than the other? The question has always been asked, is the ether carried with the Earth, or does the Earth move through the ether? And then the thing is, the ether being physical at all, is there's no way to pinpoint it. All of these people, as you find in Whitaker's book, for the hundreds and hundreds of pages, came up with all these models of the ether that couldn't possibly work.
Michaels and Worley showed that too.
That's right. Everybody came up, that's why this guy Lamour stated that let's just drop trying to say what the ether is, because we have all the interrelations handed to us through observation of electric phenomena. As Heaviside said, why should I not eat my dinner? Because I don't understand how I digest it.
When the tether was towed behind the space shuttle, went poof. I'm kind of curious, how do you see that as fitting into this framework of reference? Remember the tether that was towed behind the space shuttle?
Yeah, they're trying to drag a capacitor, right?
Well, actually, they were kind of unclear as to what they were trying to do, but the theory was they're trying to see if they could actually collect voltage from the Earth.
Well, obviously they did.
Well, they did. but the fun part was they got much more than they thought they were going to get. I thought that might be sort of interesting.
Well, the thing is now you have to remember, when you get out in outer space, the rules seem to change quite a bit, but this stuff doesn't, they don't tell you that. For example, you can't see the sun or the stars in outer space. You can see the moon, you can see your hand, you can see the spaceship, you can see rocks, you can see the planets, but you can't see the sun and you can't see the stars. So there's something about, there's a primary light and a secondary light, and then you have to figure what kind of voltage gradients exist between the Earth and the sun when Tesla says the sun is charged with 2 billion volts of electricity. The whole of the solar system, and it's the only way to explain how a planet like Pluto, because a large number of planets are lining up right now. And what this does is this causes solar flares. Okay, the physicists, you tell that to the physicists, particularly the astronomer, they'll be twitching on the floor, puking their lunch up. But nevertheless, this is well known by all RCA engineers, and it doesn't matter what physicists think, because all RCA cares about is money. And if the transmitters don't work, then the money gets cut off. So what RCA found is that planetary alignments influence the solar flares and the electrical conditions of space and cause these massive changes in radio propagation that go beyond anything you can explain with aurora borealis, or because I studied this stuff for a long time. It's no mistake with all the RCA equipment, and there's something much deeper going on here. If you look at the planets as elements of a capacitor, and there's electrostatic lines of force between all of these planets, then it seems to make sense that if they move into configuration, the lines of force will be able to join up better. And it's also a condition of capacitance, as we'll get into some of it here, is if you take two objects which have an electrostatic field between them, and the more you try to separate them, because they mechanically want to pull each other together, the more you try to separate them, the higher the voltage has to raise in order to keep the quantity of energy constant, according to the law of conservation of energy. And the voltage will continue to raise, and this is how lightning is formed, until eventually nothing can withstand that stress, and it blasts. So this is going on in outer space, and somehow, as a friend of mine said, NASA is abbreviation for never a straight answer.
Well, actually, okay, that's a very good answer. But you do have a comrade, and I'm sorry I can't remember the name now. Someone here probably knows. There's a guy who wrote a book called The Electric Universe. And he has
Yeah,
this
I'm
exact
trying to
model.
communicate with him, but he doesn't seem to be interested in anything I'm working on.
But your whole idea of the planets lining up and the
Right.
capacitance, I mean.
Well, it's
he
not
actually
my
has-
idea, it's kind of what the idea.
Right.
I'm not really creating any of this, I'm just taking all the pieces and putting them together, and just kind of, they told me in high school that I was retarded. So I'm just kind of, a homeless person that just takes books and pastes pages on, other pieces of paper in the public library.
I was accused of this, it's okay. But I
Let
mean,
me get back to this because I don't want to lose track of our concepts. So, we're talking about lines of force and capacitance. So much of the mystery surrounding the workings of capacitance can be cleared by close examination of inductance and how it gives rise to dielectric phenomena. So basically what I'm saying is our knowledge of magnetism and inductance is farther than the knowledge of the dielectric and the capacitance, because the physicists say there is no dielectric and there is no capacitance, that it's electrons. And it's action at a distance. There's no lines of force in between. It's electrons and there's no electricity. It's matter. But this is a grave mistake, and this is what we're going to climb out of. Okay? Inductance represents energy storage in the space as a magnetic field. So if we look at all those lines of force around the magnet, that represents the storage of energy. In other words, there exists there in that field the force keeping it alive, stored electrical energy, just like a bottle in that magnetic field. The lines of force orientate themselves, as we've seen, in closed loops surrounding the axis of current flow, which is basically a shadow of the magnetism. It's the magnetism scraping on the wire. That's what we call current flow. The larger the space between this current and its images and reflections, that, in other words, the wire on the other side, the more energy that can be stored in the resultant field. So in other words, the bigger the space between the wires, the more space we have, the more outer space we have, the more magnetism we can hold in that bottle. That just makes absolute physical sense. Let's continue. The process of pushing these lines or loops outward, causing them to stretch, represents storing energy as in a rubber band. The given current strength will hold the loop of force at a given distance from a conductor passing current, hence no energy movement. The situation stabilizes itself. If the flow of current increases, the energy absorbed by the field, I can't read it, someone read that for me? Or,
Absorbed by the field as
as the loops are then pushed outwards at a corresponding velocity. Because the energy is in motion, an electromotive force must now accompany the current flow in order to represent power. The magnitude of this electromotive force exactly corresponds to the velocity of the field. As we've seen, a change in magnetic field with respect to time is voltage or electromotive force. So as long as there's change in the magnetic field, there must be an electromotive force. A model would be is if you're flying down the road at a constant velocity in your car, you feel no motion. You're not being pushed forwards or backwards. But as soon as that velocity varies with respect to time, then all of a sudden there's an inertial response where you either are pulled forwards or pulled backwards. This variation in velocity, the rate of change of velocity, where velocity is analogous to magnetism through the swirling of the ether, the electromotive force results as a reaction to any type of change in that system, just as inertia. In fact, we call inductance in electronics electrical inertia. So in the motion, an EMF must accompany the current flow in order to represent power. The magnitude of this force, we'll be going through that. If the current ceases changing in magnitude, thereby becoming constant, no EMF accompanies it, as no power is being absorbed. However, if this current is decreased, and represents then a negative velocity of the field as the loops contract. Because the EMF corresponds exactly to velocity, it reverses polarity and thereby reverses power, so it now moves out of the field and into the current. Since no power is required to maintain a field, only current, the static or stationary field represents stored energy. Okay, we'll do the next page. Many interesting features of inductance manifest themselves in the two limiting cases of trapping the energy or releasing it instantly. We call these the limits of zero and infinity. In other words, time equals zero, or time is instantaneous. In other words, there's no time to grab onto. When it is switched off, the inductance drains its energy into the resistance that converts it into a form of heat. We will assume a perfect conductor that has no resistance. In other words, we have a coil or a system that's cooled to absolute zero, let's say. If we remove the current supply by shorting the terminals of the inductor, we've isolated it without interrupting any current. Since the collapse of the field produces EMF, this EMF will tend to manifest. However, a short circuit will not allow an EMF to develop across it, as it has no resistance by definition. No EMF can combine with current to form power. Therefore, the energy will remain in the field. It will be trapped. It will be closed. The door will be closed by the wire tying the two ends of the coil together and forming a complete circuit to a loop for the magnetism to be trapped inside. The experiment of this is if you take a piece of lead cooled to absolute zero and drop it in liquid helium that's cooling it to absolute zero in a magnet, is it will float on the magnetic lines of force because now it's become a perfect conductor, which is not true. It's a perfect obstructor, like Heaviside says. The magnetism cannot get into the counterspatial or interdimensional material of the metals because of the absolute zero and cause electron flow. So the so-called conductor will float on the magnetism because there can't be any change in the energy balance. So you have like a type of magnetic shock absorber or spring. It can't fall down because the magnetism will hold it up by exactly what we're talking about here. Any attempt to collapse the field increases the current but pushes it right back out. This is one form of storage of energy. Okay, now we're going to go on. Okay, we're going back to our field. This is where our energy actions are, is in this field. Let's keep going. Going back to our fields again. So this is the space we're in. Okay, now, very interesting and dangerous phenomena manifest themselves. This is particularly when you're working on DC ships. This is something you really have to watch out for. Manifests itself when the current path is interrupted. In other words, if you break the circuit wide open, like one of those vacuum switches tried to do on the substation disconnects. In this case, the resistance is best represented by its inverse, conductance. The conductance is then zero. Because the current vanishes instantly, the field collapses at the velocity approaching that of light, theoretically. That still hasn't been measured. As EMF is directly related to the velocity of flux, it tends towards infinity. Very powerful effects are produced because the field is attempting to maintain current by producing whatever electromotive force is required. That's what starts feeding these flames on the switches. If a considerable amount of energy exists, say several kilowatt hours, that's what you use in your house in one day, or 250 kilowatts for a lightning stroke. Lightning stroke has 250 kilowatt hours, or 250 units of energy we're dealing with here. The ensuing discharge can produce most profound effects and completely destroy adequately protected apparatus. So if, let's say I have a 50 horsepower DC motor, it has these giant inductance coils in it to create magnetism. Now if I go into the contactor box, I find this big resistor in there. And what it's designed to do is when that contactor opens up and tries to disconnect the inductance from the rest of the bounding electrical system, the collapse of the magnetic field will generate whatever voltage is necessary to keep jumping across those contacts, and it will leap out and kill you.
I have to stop you for a sec.
Okay.
Stephanie, you might want to change your tape now so we're in sync.
Do you want to change it?
Let me just keep going here because they're not dealing directly with this, but I don't want people's minds to go blank.
Okay, well
So if we take this magnetic field, which represents stored energy, and try to stop the field from existing or whatever voltage is necessary, so you put these drain resistors inside the motor starting boxes to absorb that blast so the magnetism can release itself in a sane rate. So this is something in DC you have to deal with this situation. What will happen is if you break the circuit instantly, we'll get it, if we can do it, it gets into another process inside the windings that will prevent it from going to infinity, and that's what we're going to go into next. The magnetism, the energy has to go somewhere and finds another route. So let's keep going. So we have another form of energy storage to try to absorb this up, and that's the capacitance. Okay, through the rapid discharge of the inductance, a new force field appears that reduces the rate of inductive electromotive force formation. This field is also represented by lines of force, but these are of a different nature than those of magnetism. These lines of force are not a manifestation of current flow, but of an electric compression or tension. This tension is termed voltage or potential difference, and these are our dielectric lines of force. So the magnetism will produce an electromotive force to try to maintain the current flow, but this electromotive force will then create a dielectric field, and this ultimately limits the situation so it doesn't go to 1 trillion volts. Usually in a big motor, it'll limit off at about 10 or 15,000 volts, but usually it'll blow holes in the windings. So let's keep going. Unlike magnetism, the energy is forced or compressed inwards rather than outwards. So we're going into that counterspatial relationship. The electric lines of force push inwards into internal space and along axis, rather than push outwards broadside to the axis as in a magnetic field. Because the lines are mutually repellent, certain amounts of broadside or transverse motion can be expected. But the phenomena is basically longitudinal. This is, we're getting to Tesla's world now. This gives rise to an interesting paradox that will be noticed with capacity. This is that the smaller the space bounded by the conducting structures, in other words, the closer the wires are together, or the closer the plates in the capacitor, the more energy that can be stored. So it's defying our concept of a bottle holding energy. In other words, in this case now, the smaller the bounding structure, the more dielectricity will hold because it's being held in counter space. So the electric field, let's go back to the electric field diagram. Okay, so these magnetic motions or velocities, okay, and these dielectrics are referred to more as torque or compression. The magnetic lines of force exist in outer space. The dielectric lines of force exist in inner space or counter space. So the electric field in between transmission lines or telephone lines or coaxial cables or any of these things represent the storage of energy in two different aspects of the dimension of space. So in other words, we could say in physics terms that there's two dimensions of space that we're dealing with here. Outer space and inner space, and these have the independent ability to store electricity, which is in there in actuality because it will either shock you or it will burn something out, or it will explode, or it will light up a light bulb, or whatever, it's there. Okay, let's go back. Okay, now where did I leave off? Okay, I'm going to go a little further. We still we're in capacitance or inductance. Do you remember?
Not sure.
You were at 13.
What's that? What level we're on?
13.
13? Okay, let's go back to 13. Okay, here we go. So the smaller the space bounded by the conducting structures, the more energy that can be stored. This is the exact opposite of magnetism. With magnetism, the units of volume of energy can be thought of as working in parallel, but the volumes of energy associated with dielectricity can be thought of working in series. So magnetism tends to deal more with the square area type of space storage, where the dielectricity is more the space in between the lines on the ruler, which can keep getting smaller and smaller, where this one keeps getting bigger and bigger. Okay, let's keep going. With inductance, the reaction to change of field is the production of voltage or electromotive force. The current or magnemotive force is what we're talking about current. We're also speaking of magnemotive force. We have to go back to our original relationship, but I can't jump so far so fast. The current is proportionate to the field strength only and not the velocity of the field. With capacity, the field is produced not by current, but voltage. This voltage must be accompanied by a current in order for power to exist. The reaction of capacitance, the change of applied force, then is the production of current. So where the magnetism's reaction was voltage, or electromotive force, the capacitor's reaction is current, or magnemotive force. So the inductance reaction of electromotive force creates a potential to charge the capacitance, but the capacitance reaction increases magnetic motive force, which tends to feed the inductance. So we have energy trapped in a self-denying situation where one storage is the antithesis of the other, and the energy can never stay put. It has to constantly go back and forth. That's how we get our frequency. You go back to the time equation. This is what determines the frequency. It has to go back and forth. It has nowhere to go, and it can't stay put. So let's say I lift off. The current is directly proportional to the velocity of the field strength, just like with magnetism. When voltage increases, a reaction current flows into the capacitance and thereby energy accumulates. If voltage does not change, no current flow, and then the capacitance stores the energy which is produced in the field. So we store the energy in the coil by tying the two leads together, but we store the energy in the capacitor by taking the two leads apart. So then if we put the coil and capacitor together, one is closed and the other is open, and we can see how this denial process starts this exchange. It's like an antithesis that can't get out of its loop. And it has to occur at a definite frequency.
So the frequency is third dimension then?
Well, no, frequency is a time dimension where the inductance and capacitance are geometrical proportions. Spatial geometrical proportions. They have no real dimensions in their own being. They're more, we'll get into that later, how the dimensions of these things are. Okay, so we're going to move off here now. If the voltage decreases, then the reaction current reverses and energy flows out of the dielectric field. As the voltage is withdrawn, the compression within the bounded space is relieved. When energy is fully dissipated, all the lines of force vanish. So what we see is when we discharge the inductance by breaking the circuit, in order to keep the situation in the realms of reality and not infinity, the dielectric field had to take all this up. So in these paragraphs, we've seen how energy is basically moved out of the magnetic field and into the dielectric field, and in the reverse situation to bring it right back. Let's go further on. Because the power supply which provides the charging voltage has internal conductance, after it is switched off, the current leaking through the conductance drains the dielectric energy and converts it to heat. This is just like the resistance did in the inductance coil. We will assume perfect capacitance having no leakage conductance. In other words, in the inductor we had perfect conductivity or zero resistance, and in this case we have zero conductance. So we're perfect insulators. The open circuit determines capacitor, no path of current flow exists by definition of an open circuit. If the field tends to expand, it will tend towards the production of current. However, an open circuit will not allow the flow of current as it has zero conductance. In any attempt towards field expansion raises the voltage, which then pushes the field back inward, so it's trapped. Therefore, the energy remains stored in the field. This energy can be drawn for use at any time. It's another form of energy storage, which exists in a conjugate relation with the storage of magnetic energy.